All right, this is so amazing to me. I mean, it wasn't that long ago, maybe 10 to 12 years ago, where I've got a movie being uploaded to YouTube right now um, on this computer. I'm talking to you with a screen, which would have taken, which takes a bunch of memory, and we're getting ready to do the next problem on a different thing. So it's just amazing to me. All right, let's take a look because this is the type of problem that would definitely wind up on. Notice the symmetry again. There's a symmetry here. What is the resultant force by the two cables supporting the stoplight in the figure? Okay, so then they're saying, well, what's the weight of the stoplight? All right, now let's take a look. The reason why this would be a good test question is because it has symmetry, and you already know the tension in the two things. And so we just break it down into its components again. We just break it down into its two components. And this is where somebody chimed in on, I'm sorry if I can't remember your name, because they were looking at this problem or one a little bit different. I think they're looking at this problem. They said, well, all I did was to find the total tension was I just divided by 2 times the cosine, and you'll see. So we'll get there. All right. So you're looking at this. You're going, I have no idea. They don't give me the mass. If I had mg, I'd be great. Well, and notice when we get the magnitude of what is the resultant force. They've already given us what the tension in the cables is. Okay. We already know what that is. Now, little geometry here. All right, let me draw it here. Here we go. So let's go ahead and go to the ladybug here. Right. So here's what we have. So we got chapter 4. I already forgot what problem this was. Sorry, my brain is turning into mush. Whoa, now I'm completely off base. There we go. Problem 16, chapter 4, problem 16. If we didn't have so many old man issues. Now, here's what we've got. And this is a great problem. Got this, it's going across here. And they said this was 60 degrees. I'm going to go ahead and put a dotted line across here. All right, they said this was 45 degrees, and they said this was 60 newtons. They said this was 60 newtons. I might add one other comment about this type of problem too. And they said that was 45 degrees. All right, alternate interior angles. Do you remember that? This is 45, and this is 45. Remember that from geometry? We're missing one thing. The stoplight, mg. All right. So we want to find the resultant force of these two cables. All right. Now, first of all, let's look at the sum of the forces in the x direction. I don't have an mg. That's in the y direction. It's not moving, so it equals 0. So let's just go through and break these guys down. Here's tx, here's t1x, here's t2x, or t1y. All right? And notice if it's 45, the sine of 45 and the cosine of 45 are equal to each other, aren't they? At least last time I taught trig 20 years ago. Yeah. So T1x and T1y have the same magnitude. This is positive, and this one will be negative, of course. So we've got minus T1x plus T1y, T2x, which is over here. All right, well, I know what they are. I can calculate them because I know that that they equal minus 60, this one would be minus 60 times the cosine of 45 plus 60 times the cosine, because they equal 0, plus the cosine of 45. Okay, so I don't even have to worry about these two. I mean, they don't do anything. I mean, they go to 0. The x components go to 0. All right. Now then, let's look at the sum of the forces in the y direction. Sum of the forces in the y direction are equal to 0, which is equal to, now notice, T1y plus T2y minus mg is equal to 0. So 2 times T sine of 45 is equal to mg. Oh, well, 2 times 60 sine of 45 equals 84.5. That's the way, we calculated mg, okay? But remember that tension, this is actually the tension going up. This is 2ty going this way. We got mg going that way. And so mg is equal to that. So that's why they came up with the same answer on both. So that one wasn't too, that's a nice little problem. That is a great little test question type thing. Well, now, one thing I want you to look at. Here's one thing I want you to see. Let's say I've got a 100 Newton, this is just sidebar. And let's say I've got one of the, a male gymnast, because they're the ones who do an iron cross, okay? And now the iron cross is that, I don't know if you can see me up here in the corner, I've kind of blacked myself out here. When they do the iron cross, they come down and they go like this. Oh man, it takes a lot of strength, and they will never ever, you know, they come to a point and then they kind of snap themselves. But if they're up here and they're coming into it like this, there is a certain point where actually the tension in their arms is getting close to infinity, and it really hurts. Okay, it's very, very painful. So let's say one of those guys weighs, you know, probably 130 pounds, which would be right around 70 kilograms or so, 75 kilograms. All right, so let's do this. So let's take a look at what happens using what we just did here. Let's see what the tension is. If I know, if I'm going to do the tension, but now I'm going to make the degrees 2 degrees. Theta is equal to 2 degrees. Let's calculate the tension for mg equal, well, 2.2 pounds or 130. Yeah, this 60 newtons? No, that's not right. Well, yeah, because I'm 110 newtons. So let's go with 75 newtons. Mg is equal to 75 newtons. Okay? About twice as big as a male gymnast that's in iron shape, you know. So let's take a look at what happens to T when the sine of the angle is 2 degrees. Okay? And so we've got this. So we've got 2 times T times the sine of 2 degrees is equal to 75. So T is equal to 75 divided by 2 times the sine of 2 degrees. That's when they're really getting down there. And I bet you this number is going to be ginormous. It better be. Otherwise, I've wasted another 5 minutes of your life that you'll never get back. 75 divided by 2. I'm kind of getting excited about this because I've never done this with a class before. Oh, so of course I hit the wrong thing. From sine of 2, and close parentheses. Yes. The tension now is 1,074 newtons. Tremendous amount of force. A tremendous amount of force. Okay. All right. Okay. So anyway, just wanted to little gymnastics thrown at you there. All right, that's it. That's it. I'll go ahead and post these guys, and we'll be on our way. There.